Apparently, Henry Ford built his first car in his shed in 1896. Useless and only marginally interesting, I suppose. But I wonder if he had any idea of how many vehicles there would actually be on the planet today. Even if he did, it's doubtful he could have imagined the environmental impact and complexity of modern motor transport. Since 1992, the new type approval regulations meant that all cars and vans had to meet new limits on the emissions they produced. Definitely something that Henry wouldn't have thought of. Now, these vehicles will need to be tested. This not only ensures that they meet all the criteria of the MOT test, but also that they are being used and maintained in an environmentally friendly fashion throughout their lives. So that brings us neatly to the subject of this video, emissions testing. A little bird tells me that emission testing requires a bit of nous, so who better to give me some background and a few tips than one of those very clever vehicle inspectorate chaps. I'm here at the VI's Bristol Training School to meet Colin Gibson. Colin is part of the MOT scheme management team. So Colin, are you going to show me the entire test procedure?
No, not today, Cleo. The video's designed for authorised examiners and nominated testers, and they're already very familiar with the standards and procedures laid down in the manuals and the other books that we give them. What we're going to deal with in the video is some of the more problem areas, and to give a little bit of background as to the history of emissions testing as well.
So where do we start?
We're going to be focusing on vehicles with advanced exhaust emissions equipment. The reason for this is that more and more of these vehicles are coming into the test, and as these vehicles come into the test, they're going to replace the ones that use lesser standards of exhaust emissions testing.
Why aren't all cars tested to the same limit?
As time's gone on, manufacturers have reduced exhaust emissions by changing the design of their vehicles in line with legislation and the rules that we've made. What we can't start doing is testing vehicles to a standard that were never designed to meet in the first place.
So how does a tester know which test to perform?
They can find that in the manual. There's a flow chart in there in the section that deals with emissions testing, and that tells the tester which standard to apply for which vehicle. It asks a series of questions based about the vehicle, and it gives the right standard to apply.
Looks a bit complicated, Colin.
Yes, it does, doesn't it? The reason for this is that the chart's got to have in it all the situations that a tester might come across and all the different vehicles that they might have to test. But if you follow it through stage by stage, it is quite simple. But what I'm going to focus on are the ones that testers test the most of, which are passenger cars. Now, there are a couple of areas that do cause confusion, and I'll try and clear those up. First of all, looking in the manual, it may seem odd that there is a separate criteria for cars registered between 1992 and 1995, when today's standards were set in 1992. This was to allow manufacturers to carry on selling cars that they'd already made, while they were starting to manufacture cars that met the new standard.
So if the tester has a 1992 car, what test should he perform?
Now, when a tester's testing a car that was first used on or after the 1st of August 1992, and they can find an exact match for the vehicle in the data emissions book, then they should test to the vehicle-specific limits for that vehicle. Remember that the data book matches the database in your test equipment, and it's updated annually. If they can't find an exact match, then they should test to the old 2 gas limits.
What's an exact match?
Now, an exact match can include the make and model of the vehicle, the engine size, and possibly the engine code for that particular type of vehicle. Now, the engine code becomes important later on when we're thinking about vehicles that were first used on or after the 1st of August 1995. If a tester finds an exact match in the data book for one of those, then the test to the vehicle-specific limits for that vehicle. If they find an exact match for everything except for the engine code for that particular vehicle, then they should use either the default limits for the advanced emissions test or they should use the vehicle-specific limits for that nearest match. The tester must use whichever is the less demanding of these limits. Now, if they can't find any sort of a match, and it's first used after the 1st of August 1995, then they should go to the default limits and test to that. Now, talking about engine codes, we would find these under the bonnet.
So this is a brand new car, Colin.
Yeah, that's right. We've chosen a brand new car to make it easier for people to see what we're looking at.
So where is the identifying code?
Well, on this particular one, the engine identifying code is on the engine block, down at the front of the engine.
Oh, yes. Oh, that's pretty
Just
clear.
down there, you can see it. Now, again, because it's a brand new car, it looks nice and easy to see, but obviously the cars that testers are looking at, might have grease and grime and dirt on it. So they need to know where to look to be able to clean it off and find it.
Well, how do I know it's the right number?
Well, the engine identification code, you can see down there. You can often look in the data emissions book, or sometimes even in the manual, to give an idea of, first of all, where to look, and secondly, to give you an idea of what the number or code should look like.
But what if the engine's been changed?
If you've got a vehicle that's got another engine, a different engine fitted from original, then the tester should apply the limits that are relevant to the older of the two. If it's got an old engine in a new vehicle, they should test to the age of the engine. If they've got an old vehicle with a new engine, they should test to the age of the vehicle, so they test to whichever's the oldest.
So why should I put so much effort into finding the right engine code?
It's important that a tester makes every effort to find the engine code to do a proper test. And that's to make sure that everybody gets a fair test, a test that's for that particular vehicle. Now, bearing in mind that a tester only needs to do this if the emissions book or if the emissions tester machine tells them to look for an engine identification code. Remember, the emissions data book and the manual give an indication of where to look. Sometimes the code can be found on the VIN plate.
And what if the engine's been modified?
If it's been modified, then if it's an exact match in the emissions book or on the database of the emissions tester, then they've got to apply those limits. And what matters is the gases that come out the pipe. If it passes, that's fine. If it doesn't pass, there might need to be some work done on the engine to take it back to the original design.
If more and more vehicles are going to need an advanced emissions test, is that going to make all two-gas testers obsolete?
No, it doesn't, because there are still vehicles that need a two-gas test to be done on them, and they can keep their equipment to do those tests, provided it's kept properly maintained and calibrated.
The advanced test is more time-consuming.
Yes, it is. The reason is because the engine's tested at different speeds. It needs preconditioning to make sure that the catalytic converter's lit. Sometimes you might need to do the preconditioning twice. If that's the case, the machine will prompt the tester to do that. The reason why the test involves all this is to make sure that the test is fair to all the vehicles that are going to be tested, and that the vehicles are in the ideal conditions to be tested.
What are the ideal conditions for an advanced test?
First of all vehicles that are going to have an emissions test need to have a purge test done, whether they've got catalytic converters, advanced emission systems, or whether diesel vehicles, they all need to have a purge test done.
Want to start the engine, please, driver?
Now, with vehicles with advanced emissions control equipment on, it's important to make sure that all the auxiliary electrics are turned off. The only thing that should be switched on is the ignition.
Raise the engine speed into the box.
It's also important that the engine's at the right running temperature, the catalytic converter's lit. It's not sufficient, really, to leave the engine ticking over to get it warm enough. It's better if it's been driven, so we let testers do the emissions test when the vehicle first arrives on the forecourt, provided it's done by the same tester that's going to do the rest of the test. They can get the readings, they can keep the printouts with the vehicle until they do the rest of that test sometime later in the day.
Why should a cat be used?
It's one way that manufacturers have of reducing the emission levels of their vehicles in line with legislation. The legislation doesn't specify how a manufacturer will reduce these emissions, but you know, the catalytic converter is the most popular one. It's important for testers to realise that it's the emissions that are being tested, not the operation of the cat. Even on a vehicle without a cat that a tester thinks should have one, a missing cat is not a failure item if the exhaust system's otherwise okay. All the vehicle has to do is meet the emissions limits. If they have a vehicle that fails, then there are several reasons why it could fail, which are nothing to do with the catalyst fault. You know, it can be other things.
How do these systems work?
Well, to show you that, we need to look underneath the vehicle. Now, the components in an advanced emissions exhaust system, you've got the oxygen sensor there, and I'll talk about what that does in a second. Further back, you've got the catalytic converter there. Now, for the catalytic converter to work properly, it's got to have the right gases going into it. So we need to control those gases. Now, the way that the gases are controlled is with this oxygen sensor. Now, if there's too much oxygen, it'll send a signal up this green wire to the engine management system to say that the engine's running weak. If it's got too little oxygen or too much fuel, then it'll send a signal up the wire to tell the engine management system that it's running too rich.
Right.
Now that'll alter the engine management system to alter the mixture strength going into the engine so that you're getting the right mixture strength coming out. Now what the oxygen sensor does, it tries to tell the engine to keep running with a mixture strength that's ideal or within the manufacturer's limits for the mixture strength. Now the ideal mixture strength is called the lambda, and you know, in technical terms it's 14.7 parts of air to 1 part of petrol. Now that's why this is called a lambda sensor. So to summarise this system known as the closed loop, starting at the engine's mixture strength system, the injectors for example, the air-fuel mixture flows into the cylinder where it's burnt. After this, the exhaust gases pass the lambda sensor. Now this sensor measures the oxygen content and sends an electronic signal back to the engine control unit, which tells the mixture strength system at the start of the loop whether to make the mixture richer or leaner, so completing the loop. Now, the reason why it's so important that this mixture strength is right is because the gases that pass through this, they go along there and they go into the catalytic converter. Now, for the catalytic converter to work properly, to convert the dangerous gases into harmless gases, it's got to have the right gases going into it to convert into the correct gases coming out of it.
I see.
If it fails a test, it's not necessarily going to be the catalytic converter that's faulty. Like I said, the catalytic converter depends on the right gases being given it to convert them properly. Now, if it's not getting the right gases, it might be because the oxygen sensor's faulty, or there might be a hole in the exhaust somewhere that's causing the wrong signals to go to the oxygen sensor, or it might be a misfire, or there might be something wrong with the engine management system. So a repairer ought to ensure that the closed-loop system is operating correctly before questioning the operation of the catalytic converter.
So all the emissions are tested once they've passed through the catalytic converter?
That's right. The gases that we measure are the ones that have passed right through the system, through the catalytic converter and come out of the tailpipe.
So what if you have two exhaust pipes?
If you've got two exhaust pipes, a tester should take two readings, one from each exhaust pipe, and average the two out.
Oh, Colin, lots of covers and things in there. Is it difficult at times to find out where to connect your gas analyzer?
Yeah, one of the problems that we hear about is that authorised examiners and testers have problems connecting the gas analyzer to pick up the engine speed sensor. Now, all the exhaust gas analyzer manufacturers had to have at least 3 methods of doing this. I mean, some can pick it up from the ignition leads, which I think is the most common. You can get some that'll pick it up from an injector pipe. What I suggest for authorised examiners to do is to find out from the equipment manufacturer if they've got all the leads that are necessary. They'll probably have to buy any extra ones, but it's worth finding out to see whether or not they've got everything they need to do the test.
More and more people are going for personal imports. What will happen when they come to be tested?
Well, what will happen with them, I mean, it's in the manual, so testers can read it in the manual. But basically what happens is we test them according to the date of first use. The only exemption to this is if the owner can present to the tester a letter from the vehicle manufacturer stating that the engine, as originally installed, could not meet the British emission standards for that age of vehicle. In this case, the tester should test to the next less demanding limit.
As a customer, I get a personal printout. How long should the MOT station keep their record?
Well, they need to keep a copy of the printout for at least 3 months. And it's probably a good way to keep them, to put them with the carbon copy of whatever certificate they issue with it.
What about kit cars? Are they a problem?
No, because kit cars and Q-plated vehicles, they're tested like a pre-1975 vehicle.
And Colin, what do I do if I want to get some more advice?
Well, there's lots of places to go, Clay. There's the local area office, where they'll be able to help you. There's the MOT helpline, which we're going to give the number at the end of this video. As well as that, we run training courses to show people how to inspect vehicles. And we've got a video called No Smoking that's all about testing emissions on all sorts of vehicles.
Oh, well, thank you so much, Colin. And now I'm off to the shed to continue with my great environmental transport project.
Bye, Clay. Good luck.
Well, they say innovation is the key to getting ahead in this ever-changing world. All my own work, you know. I thought I'd call it the Clio. Original, eh? Don't forget the MOT hotline and our website. If you're interested in VI training courses or other videos in the MOT Matters series, an address for more details and where to order is on the back of your video case.